Okay, so this is going to be 10.3, calculus with polar coordinates. So what I did is that I put a couple of formulas here. These formulas will be given to you. You will just have to be able to know how to use them. So what I did is I wrote them down so you can write them down and pause the video. So the first thing is kind of like, this is what we're going to be given. We're going to be given some sort of polar stuff in polar coordinates. And you have these things. So in order to find the slope of some sort of polar equation, then you can find dy over dx simply by this formula. This formula is very similar to the parametric equations formula, so this should look very, very familiar. So this is kind of how you find the slope, and then from the slope you can find the equation of the tangent line and all that other stuff. Here we have horizontal tangents and vertical tangents. So basically, remember horizontal tangents, what you want to do is you want to take the numerator of the slope formula and set it equal to 0, provided that the bottom part is not also 0. And then to find the vertical tangents, what you got to do is set the denominator equal to 0. Okay, provided that the numerator is not equal to 0. And that's because you do not want the 0 over 0 thing, right? Because it's indeterminate. And basically, if this does happen where you have a value of theta where it's both on the numerator and the denominator, then what you have to do is that you have to take the limit of that. So to see which one it is it a horizontal tangent or is it a vertical tangent? So that can be this is really, really tricky. You have to be very careful with those. You have areas between bounded by a polar curve. So that's just this guy, very basic. You have areas between curves. So this is basically the outer area versus the inner area. So we will talk about those two different graphs. We have the arc length of a polar curve. So you want to know how long this polar graph is. And then you have surface area. So you're rotating this polar graph about either the x-axis or the y-axis. In this case, when you rotate it about the x-axis, you're actually rotating it about the polar axis. And when you're rotating it about the y-axis, you're actually rotating it about theta equals pi over 2. And they're just a whole bunch of messy formulas. So the formulas are basically the same as we've been talking about in parametric equations. These formulas will be given. The only tricky part that I think is just the limit parts and also the areas, because you might encounter a lot of trig stuff. So you have to be very, very comfortable with the trigs and the trig identities. And what I ended up doing is I posted a trig identity worksheet with all the formulas that you learned from trig and pre-calc in there, so you can go ahead and use them as well. So here what we want to do is we're going to do this first example. So we want to determine the equation of the tangent line to r equals 3 plus 8 sine theta at theta equals pi over 6, okay? So if you remember, in order to find the equation of the tangent line, that basically means that we want y minus y1 equals m times x minus x1. That's basically what that means. So in order for us to figure out, we need to figure out what y1 is, what m is, and what x1 is. Okay, so the first thing that they tell us is that theta is equal to pi over 6. So in order for me to figure out what x and y is, well, let's first start off with x. Well, I need to figure out what this x1 is, so we know that x is equal to r cosine theta, okay? In this case, what we want to figure out is, okay, what exactly is going to be theta equals pi over 6? What is going to be the value of r? Because I know that theta here is going to be pi over 6, but what is this r? So what I'm going to do is I'm going to take this r equals 8 plus sine 8. Oops, that's wrong. 3 plus 8 sine theta. So I'm going to have 3 plus 8 sine of pi over 6. Okay, so this is going to be 3 plus 8 times 1/2, which is going to give me 7. Okay, so r equals 7 when theta is equal to pi over 6. So what I'm going to do is I'm going to plug it up in there. So it's going to be 7 times the cosine of pi over 6. And we're going to get 7 square root of 3 over 2. Okay, now we're going to do the same thing for y. So y is going to be equal to r sine theta. So we're going to have 7 sine of pi over 6. And what we're going to have is 7 over 2. So basically, this guy is going to be my x1. This guy is going to be my y1. Okay, so we basically just found my y1 and my x1. Okay, now what we want to find is find my m. Okay, so now we got to find m. So find my slope. And in order to do that, well, we know the formula for the slope. Okay, the formula for the slope is given to us up right over here. This is how we find the slope. Okay, dy over dx. So let me just write it down. So m is going to be equal to dy over dx, which is equal to dr over d theta sine of theta plus r cosine theta divided by dr over d theta cosine theta minus r sine theta. Okay, so what we're going to do, we have r equals 3 plus 8 sine theta, so the derivative of that is just going to be 8 cosine theta. Okay, then we have a sine theta plus r. It's just gonna, I'm gonna leave it as is for right now, and then I'm gonna have this cosine theta divided by dr over d theta again. That's gonna be 8 cosine theta. Then we have a cosine theta next to it, then minus r, and then sine theta. Okay, now notice we already know what r is. So r is just equal to this guy, this 3 plus 8 sine theta. So that's what we're going to plug in here. So we're going to have h cosine theta sine theta plus, what was it? 3 plus 8 sine theta cosine theta. And this is going to be divided by 8 cosine squared theta minus 3 plus 8 sine theta sine theta. Okay, so on the top, okay, I'm going to distribute this out, and I see that you're going to have this and this be the same, so that's going to give me 16 sine theta cosine theta, and then you're going to have this plus 3 cosine theta, and then on the bottom, okay, oh god, this is going to be, okay, so I'm going to have this 8 cosine squared theta minus 3 sine theta minus 8 sine squared theta. Okay, so not the prettiest thing in the world, but you can reduce this using many identities, but I'm just going to leave it like that. So now what we want to do is we want to plug in, notice that we only have theta, so we want to find the slope at pi over 6. So dy over dx, what I'm going to do is I'm going to plug in theta equals pi over 6. So you're going to have 16, I'll write this up here. You're going to have 16 sine of pi over 6 cosine of pi over 6 plus 3 cosine of pi over 6 divided by h cosine squared of pi over 6 minus 3 sine of pi over 6 minus 8 sine squared of pi over 6. Okay, and you can put this in your calculator, and what you're going to get is 11 square root of 3 over 5. Okay, and then what you're going to do, okay, so we have our slope, which is our m. Now we have our x1 and y1. So let's go ahead and just do y minus y1 equals m times x minus x1. And y1 in this case is 7 over 2. M in this case is 11 square root of 3 over 5. And then x minus 7 square root of 3 over 2. So obviously this is not the most beautiful answer, but let's just leave it like that because you can already see that this is really computational. There's a lot of sines and cosines, and plugging it in can be really, really scary. But make sure that you put this in your calculator, and make sure that your calculator is on radians as well. Try this problem. So given the cardioid r equals 1 plus sine theta, find the slope of the tangent line at pi over 3. Then find the points where the tangent is horizontal or vertical. So you don't necessarily have to graph this. It's not really necessary. If you really want to graph it, you can. But it really isn't necessary. But you know that this is going to be heart-shaped, and it's kind of like it's a sine function. So kind of looks like this. Oh, let me just draw it a little differently with a different color. So it kind of looks like this. So it kind of looks like a little heart, upside down heart. Okay, so this is kind of like what the graph looks like. And remember, it's a sine one, so it's going to be on the y-axis. Okay, so you want to find where exactly all of the vertical and horizontal tangents are going to be at. Okay, so basically problems that look like this, like this, like this, like this. Right, all of these guys. So you want to find all those different points. So graphing it doesn't really tell you, it kind of gives you an idea of where it's at, but actually doing the problem is what might take a while. So the first thing that we want to do is find the slope of the tangent line at pi over 3. So we just want to find the slope. We don't want to find the tangent line itself, which is great, okay? Because you saw how long that takes. So dy over dx, let's start off by writing down the formula. dr over d theta, sine of theta, plus r cosine theta, divided by dr over d theta, cosine theta, minus r cosine theta. Okay, so let's go ahead and start off by writing this thing. Oh, this should be a sine theta. So let's go ahead and start off by taking the derivative of this guy, dr over d theta. That's just easy. It's just going to be cosine of theta. And then we have a sine theta. And we're going to write the r, which is 1 plus sine theta, cosine of theta. And then on the bottom, you're going to have dr over d theta, which again is cosine. Then times cosine theta minus 1 plus sine theta times sine theta. Okay, so let's go ahead and clean this up. So you have cosine of theta, sine of theta, plus cosine of theta, plus cosine of theta, sine theta, divided by cosine squared theta minus sine theta minus sine squared theta. Okay, and then I can group these two guys together. That's just going to give me, so you're left with cosine theta and then plus 2 cosine theta sine theta divided by cosine squared theta minus sine squared theta minus sine theta. Now you'll see why I did cosine squared theta and sine squared theta together. So this is basically what it is. And you'll actually see what I'm going to do in a second and why these trig identities actually are really useful when you're doing these problems. So now that we have that, all we want to figure out is the slope of the tangent line when it's pi over 3. So I'm going to write dy over dx, and I'm just going to evaluate this when theta equals pi over 3. So I'm going to have cosine of pi over 3 plus 2 cosine of pi over 3 sine pi over 3 divided by cosine squared pi over 3 minus sine squared pi over 3 minus sine of pi over 3. Okay, and if you go ahead and do this in your calculator, you're going to get -1. Okay, so that's basically going to be the slope of that tangent line. And so basically at pi over 3 is around this area. Okay, so around here, you can see that the slope of the tangent line is decreasing, and the slope actually is about -1. Okay, all right, so now what we want to do, we got that guy. Now we want to find the points where the tangent is horizontal and vertical. So if you remember, the way that we find horizontal and vertical tangents is setting dy over d theta equal to 0 and setting dx over d theta equal to 0, which is basically the numerator and the denominator. So this is going to be really tricky, especially if you're not comfortable solving trig equations. It's going to be a little challenging for you. So first, let's start with the horizontal tangents. I'm just going to write ht for that. So what we want to do is take the numerator, which is dy over d theta, equal to 0. So here dy over d theta is going to be this guy. So this cosine of theta plus 2 cosine of theta sine of theta equals 0. Okay, so now what you want to do, let's factor out a cosine of theta. You're going to get 1 plus 2 sine of theta is equal to 0. So we have that cosine of theta equals 0 and 1 plus 2 sine of theta equals 0. So the cosine of theta is equal to 0 when theta is equal to pi over 2 and 3 pi over 2. Okay, so that's when that is equal to 0. And this is going to be sine of theta equals -1/2. And this happens when theta is equal to 7 pi over 6 and 11 pi over 6. Okay, so you have to be very, very good with your trig at this point, okay? And if you don't know where these points are, make sure that you know how to derive the unit circle. Do something, okay? So those are my vertical points, my points of theta, okay? We still got to find r, but let's start out with our vertical tangents now. And my vertical tangents, let me change the color to blue. My vertical tangents, what we want to do is set the denominator equal to 0. And the denominator is going to be this dx over d theta. Okay, so my dx over d theta is this guy on the bottom. So you have this cosine squared theta minus sine squared theta. Oh, what was the other one? Minus sine theta. Okay, so at this point, you have to be really, really smart about what you want to do. So one of the things that I see is that you have a sine theta. This is actually a trig identity, okay, that you can kind of use. So cosine squared theta minus sine squared theta actually gives me 1 minus 2 sine squared theta, then minus sine theta. So then I have a sine theta all the way around. I'm going to divide by a negative. So I have negative 1 plus 2 sine squared theta. Plus sine theta equals 0. I'm going to write this as 2 sine squared theta plus sine theta minus 1 equal to 0. This is a reducible quadratic, so you can just factor this guy out. This is going to just be 2 sine theta minus 1, and then sine theta, what is this, plus 1? Yes, plus 1. Okay. So now all we got to do is just take it out. 2 sine theta minus 1 equals 0. Sine theta plus 1 equals 0. So we get that sine theta here equals 1/2, and sine theta here is equal to negative 1. So now let's solve for the value of theta. So theta here, we have to figure out where is this going to be 1/2. Well, theta is going to be 1/2 at pi over 6 and 5 pi over 6. And then here theta is going to be equal to negative 1 at 3 pi over 2. Okay, so now what we want to do, because we're not done yet, is notice we got to check out first the vertical tangents and the horizontal tangents. Did any of these points match up? And yes, they did. There's one point that matched up in both cases. And that one is the one that we have to take care of. The 3 pi over 2 showed up in both the vertical and the horizontal tangent. Okay, so 3 pi over 2, is it a vertical tangent or horizontal tangent? So there's two ways that you can do this. One way is looking at the graph. And if you see at the graph, you can see that here's theta equals 3 pi over 2. And you can see that you have a vertical tangent. Okay. Now let's say you didn't have the graph, or the graph was really complicated. Well, one way that we can do is actually take the limit at this as theta is approaching 3 pi over 2. So limit as theta is approaching 3 pi over 2. Okay. So what we're going to do is we're going to put in what our function, so it's going to be cosine of theta plus 2 cosine of theta sine theta divided by cosine squared theta minus sine squared theta minus sine theta. Okay, so you have the limit as theta goes to 3 pi over 2. And now what we're going to do is we can factor the top and the bottom just like how we did. So on the top we had a cosine of theta, 1 plus 2 sine of theta. And on the bottom one, the way that we factored it was 2 sine theta minus 1 and sine theta plus 1. Okay, so I'm just using the factored forms. Okay, now the one that's really giving me an issue is basically this cosine theta, because that's where that one, the pi over 2, 3 pi over 2 came from. And also this guy. These two gave me an issue. So I'm going to group those together. So the limit as theta goes to 3 pi over 2 of cosine of theta divided by sine theta plus 1. So that's the one that gave me an issue. And then using properties of limits, I can just multiply this by the limit as theta goes to 3 pi over 2 of the second part. 1 plus 2 sine theta over 2 sine theta minus 1. Okay. So now what I'm going to do is that I can easily plug in 3 pi over 2 in here. Okay. And when I plug in 3 pi over 2, I'm going to get negative 1/3. Okay, now what I want to do for this guy, well, let's just use L'Hopital's rule. Okay, and when I use L'Hopital's rule, I get limit as theta goes to 3 pi over 2. And then on the top, I'm just going to get negative sine theta, and on the bottom, I'm going to get cosine of theta. Okay. All right, now we have to be very careful, because now what we want to do is that you have this limit as theta goes to 3 pi over 2. Notice that if I put 3 pi over 2 in here, you might get a 0 on the bottom. Okay, you're going to get a 0, and on the top, you're going to get a 1. So maybe this might go to infinity. Okay, so a way that you can kind of test this out is that you have the limit as theta goes to 3 pi over 2. Let's take it from the positive side of tangent of theta. And let me take this negative out. Times negative 1/3. Well, tangent, if you think of what tangent looks like, okay, so tangent from negative pi over 2 to pi over 2 looks like this. So that means if I continue on at 3 pi over 2, you can see that this is going to infinity. So you're going to have negative infinity times negative 1/3, which is going to give me positive infinity. Okay, so basically what this means is that at 3 pi over 2, you have a vertical tangent. Okay, so basically my horizontal tangents, you have theta equals pi over 2, 7 pi over 6, and 11 pi over 6. And then my vertical tangents, you have theta equals pi over 6, 5 pi over 6, okay, and 3 pi over 2. What you really have to do is figure out what the r values are. So you're going to plug in back into r equals 1 plus sine 2, no, that's not 2, plus sine theta. And what you're going to do is you're going to plug in all of these points into sine r equals 1 sine theta. So for horizontal tangents, this is what you're going to get. So when you plug in pi over 2, you're going to get 2 comma pi over 2, then 1/2 comma 7 pi over 6, and then 1/2 11 pi over 6. And for the vertical tangents, what you're going to get is theta is equal to pi over 6, plug in pi over 6, you're going to get 3/2. Whoops, that's wrong. You plug in pi over 6, you're going to get, what is this? 3/2 pi over 6. And you plug in the other one, you're going to also get 3/2, 5 pi over 6. And then when you plug in 3 pi over 2, well, that's going to just give me, what is that? Negative 1. Negative 1, that's going to give me 0. Okay, so here are my horizontal tangents, my points and my horizontal tangents and vertical tangents.